Welcome to this 4-part video series, The History of Agile. The goal of these videos is to explain the history of where Agile Scrum came from, who contributed to this movement, and where it's going, trends in the market. The big question, why is Agile the preferred method for product and software development and delivery and executing work? This series is in 4 parts. Part 1. This part will start with the origins of the scientific method and its evolution into the PDCA cycle. Part 2 will look at the history of Lean. Then in Part 3, we'll go over the advent of Agile and Scrum. Finally, in Part 4, we'll go over the use of Scrum and its future in the marketplace. This history will provide a solid foundation to your understanding of and appreciation for the Scrum framework in particular and the Agile systems in general. So let's start at the beginning. Let's go all the way back to Aristotle, the first scientist. Back around 322 BC, Aristotle developed what we know as deductive reasoning, or deductive logic, which links a premise with a conclusion. In deductive reasoning, a conclusion is reasoned from one or more premises, narrowing other considerations until only the conclusion or conclusions are left, and is seen as logically true. Like Sherlock Holmes, you make observations and you draw conclusions. Deductive reasoning is often called top-down logic. If something is true for a class of things in general, it is also true for all members of that class. It was the Greek mathematician Ptolemy, also a geographer, astronomer, and poet, who was a highly influential thinker who greatly advanced the scientific thinking of Aristotle. Ptolemy not only drew the maps that would later be used by Christopher Columbus, his writings on harmonics in music, and in the science of optics that would pave the way for another great thinker 1,000 years later. The Iraqi mathematician Ibn al-Hazan is often called the second Ptolemy. Al-Hazan was also an astronomer and mathematician who is credited as a leader in the use of empiricism and learning through testing, what we call today the scientific method. With his emphasis on empiricism, he was known to have said, "If learning the truth is the scientist's goal, then he must make himself the enemy of all that he reads." Al-Hazan believed we must test what is written through experimentation, rather than accept it blindly as true. Al-Hazan's pioneering work in the field of optics, and notably his methodology, influenced European scholars all the way to the scientific revolution in the Renaissance, which leads us to 2 prominent thinkers of the late 1500s to early 1600s, the first being Italy's Galileo Galilei, a mathematician, astronomer, physicist, engineer, and philosopher, and the man we call the father of modern science. The other is his contemporary, England's Sir Francis Bacon, called the father of empiricism. Bacon was a philosopher, statesman, scientist, jurist, orator, author, who was also once the Lord Chancellor of England in the time of William Shakespeare. Galileo contributed to knowledge improvement by asserting that the laws of natural physics had their basis in mathematics. He was often willing to change his views in accordance with observation. In order to perform his experiments, Galileo had to set up standards of length and time so that measurements made on different days and in different laboratories could be compared in a reproducible fashion. This provided a reliable foundation on which to confirm mathematical laws using inductive reasoning. Remember we said Aristotle's deductive reasoning was top-down? Well, inductive reasoning is bottom-up. Instead of going from the general to the specific, inductive reasoning goes from the specific to the general. Premises provide the evidence of the truth, pointing to a conclusion. Unlike deductive arguments, inductive reasoning allows for the possibility that the conclusion is false, even if all the premises are true. Instead of being valid or invalid, inductive arguments are either strong or weak, which describes how probable it is that the conclusion is true. Bacon emphasized that scientific knowledge should be based only upon inductive logic and observations of nature. Bacon's approach was for the scientists to be both skeptical and methodical, to prevent them from misleading themselves. Bacon is credited with codifying the methodology used today throughout the sciences, which we call the scientific method. You learned it in grade school. This is the scientific method. You observe something in nature, which puts a question in your mind. So you come up with a hypothesis. Then You make a prediction of what the answer will be. Then you test your theory. Then you analyze the data, which may lead you to renewed thinking on the subject, which could lead you to a new hypothesis, which you predict and test again until you develop a theory based on your empirical data. And you can start all over again based on your new theory. Voila, the scientific method. It may seem quaint and obvious to consider a time when we didn't use the scientific method of evidence gathering and testing to reach a truthful conclusion. However, the very reason to study the history of knowledge or the history of truth-finding is to understand that thinking does evolve over time. In fact, even the scientific method has been improved upon in our modern era. In the 20th century, during a time of rapid manufacturing growth, a movement formed to find ways to improve the way groups worked. Walter Shewhart worked for Western Electric, one of the companies that eventually became AT&T. His insight was to find a process to reduce variation as a way to improve quality. The constant evaluation of management policy and procedures leads to continuous improvement. William Deming, an electrical engineer and statistician who became a popular educator, author, and lecturer, and a noted consultant to the automobile industry, popularized one of Shewhart's more lasting contributions. In the early 1950s, Deming was working on the Japanese census for the U.S. Army. This led to his becoming a trainer of statistical controls to engineers around the country, and eventually at Sony, where he became better known. His introduction of Shewhart's ideas are credited by many in Japan for helping that country out of its post-war economic slump, and on the road to becoming the second largest economy in the world. Deming's message was that quality is everyone's responsibility. His lectures spoke of how a company can improve service through better design, the importance of achieving uniform product quality, improving product testing, and pursuing foreign markets. Deming's work and fame popularized the PDCA cycle, a process originated by Shewhart, which has the idea of deductive and inductive learning built into the learning and improvement cycle. In the Deming wheel, or PDCA cycle, first we plan, establish objectives and processes. Then we do, we implement the plan. Then we check, meaning we assess the collected and measured results. And finally, we act. We apply changes based on results. PDCA. The PDCA cycles are put to work in companies around the world as a method, a pathway towards self-improvement. The model for improvement is a business management framework for accelerating improvement, typically within a company. The model is based on 3 fundamental questions. What are we trying to accomplish? How will we know that a change is an improvement? And what changes can we make that will result in improvement? Any effort to improve something should provide the answers to these 3 questions. The answers could be answered in any order. These 3 questions, combined with the plan, do, check, act, PDCA cycle, forms the basis of the model. William Edwards Deming became a guru of the American auto industry and American practices in general. Deming taught better design of products to improve service, higher level of uniform product quality, improvement of product testing in the workplace and in research centers, greater sales through side markets. His successful principles of emphasizing quality and customer satisfaction that helped turn around Sony, Fuji, and Toyota were embraced in this country, creating a revolutionized management culture with the widely adopted TQM, Total Quality Management, and Six Sigma. Deming's basic philosophy was set down in these 14 points. 1. Create a constant purpose for improving products and services. Plan for the long term, resisting short-term solutions that compromise quality. 2. Adopt the new philosophy. Be prepared for a major change in the way business is done. It's about leading everyone to quality output, not simply managing. 3. Stop depending upon inspection to achieve quality. Deming said, finding what's wrong is not improving the process. If there were a fire in this building and we put it out, that's not improving the process. That's putting out fires. 4. Use a single supplier for any one item. Instead, minimize total costs by working with a single supplier. 5. Improve constantly and forever every process for planning, production, and service. Just keep doing plan, do, check, act. 6. Use training on the job. Build a foundation of common knowledge and train for consistency. Train workers to see the role they play in the big picture. 7. Adapt and institute leadership. Don't just supervise, support each staff member so that they can do his or her best. Be a coach instead of a policeman. 8. Drive out fear. Workers do their best when they feel valued, free from the fear of ridicule, demotion, or being fired for expressing their concerns. 9. Break down barriers between staff areas. Using cross-functional teamwork can build understanding between departments and reduce adversarial relationships. 10. Eliminate slogans, exhortations, and targets for the workforce. Don't let catchphrases like excellence in service stand in for leadership. Communicate your expectations and then praise people face to face for doing good work. 11. Eliminate management by quota. Deming said that production targets encourage high output and low quality. 12. Remove barriers that rob people of pride of workmanship. Allow everyone to be proud of their work without being rated or compared. 13. Institute a vigorous program of education and self-improvement for everyone. 14. Put everybody in the company to work accomplishing the transformation. Methodology alone won't bring success to a company. Much depends on the context, a company's leadership, its culture, the ownership, their funding, etc. What we see is that today's best practices for business stand on the shoulders of a long history of critical thinking. Our next video, The History of Lean, will further our study into the use and future of Scrum.